Asthma is said to have been first identified and named by Hippocrates around 450 BC. But for centuries, it was misunderstood and, in some cases, was even attributed to psychological and emotional instability. Although most people today are familiar with the trademark symptoms of asthma, wheezing, coughing, breathlessness, chest tightness, from chronically inflamed airways and passageway spasms, the reality, according to the Centers for Disease Control and Prevention, is that, in most cases, we don't know what causes asthma, and we don't know how to cure it. According to the American Asthma Foundation, the condition afflicts about 23 million in the United States, and it is one of the most common long-term diseases in children. Most asthmatics use bronchodilators, which reverse airway smooth muscle contraction, and anti-inflammatory drugs, which suppress airway inflammation, but many patients do not respond well to existing therapies. These are the different bronchodilators. Research into asthma crosses into multiple fields, including immunology, gene expression, signal transduction, and ion channel regulation. The authors stress, asthma is a disorder presenting dysfunctional elements at all cellular levels in the airways, and ion channels regulate, one way or another, the function of all airway cells, although many candidate genes have been linked to asthma through various means, including animal models, linkage analyses, and genome-wide association studies. The allergic origins of the disease remain poorly defined. There are 5 main types of asthma: atopic asthma, which is linked with classical type 1 LGE-mediated hypersensitivity, allergen sensitization, seen from childhood, positive history of asthma in family and skin with being test positive. Non-atopic asthma includes non-allergen sensitization, no history and skin test negative, drug-induced asthma including sensitive to drugs like aspirin extra, occupational asthma including stimulants such as chemical drugs, gas, fumes and organic products. Exercise-induced asthma begins after exercise and stops after 30 minutes, which worsen in cold and dry climate. Allergic asthma, the prototypical form that is addressed in clinical studies, is generally construed as a syndrome resulting from the interaction between genetic and environmental factors. The authors note that the experimental modeling of allergic responses in asthma is problematic. In contrast with the animal models in which T helper 2 (Th2) cell response is the dominant feature, in human asthma, an initial exposure to allergen results in Th2-dependent stimulation of the immune response that mediates the production of IgE and cytokines. Re-exposure to allergen then activates mast cells, which release mediators such as histamines and leukotrienes that recruit other cells, including Th2 cells, which mediate the inflammatory response in the lungs. The complex array of signaling reactions that underlie asthma are not easily reduced to commonly used aspects of animal models. 2-adrenergic receptor 2AR agonists are the most effective bronchodilators and relax airway smooth muscle cells through increased cyclic AMP concentrations and directly opening large conductance CA2 channels. Meanwhile, glucocorticoids are the most effective anti-inflammatory treatments and switch off multiple activated inflammatory genes through recruitment of histone deacetylase 2, activating anti-inflammatory genes, and through increasing mRNA stability of inflammatory genes. Barnes writes that our relatively good understanding of how current asthma therapies work, in terms of their biochemical mechanisms, opens the door to both tweaks to existing treatments and invention of entirely new ones in the future. As others have before it, this thematic mini-review series aims to link biochemical processes to the understanding of an important clinical challenge. Over the past half-century, both the incidence and the severity of asthma have increased worldwide, further burdening public health service providers in developed and developing nations alike.